Alright guys, let's go. Get your notes out. Today what we're doing is factoring trinomials. We are going backwards from yesterday's lesson. Yesterday I gave you two factors and you multiplied them together to form a trinomial. I gave you two binomials, you multiplied them together and you came up with a trinomial. Today we're doing the exact opposite. So let's just look at what we did yesterday. Yesterday you had something like x plus 2 times x minus 6. Those are two binomial factors. And they're factors because they're getting multiplied by each other. You multiplied them, and then you got four little products, remember? And the two in the middle were like terms, and you put them together, right? So let's just go through those steps of what we did yesterday. What was x times x? X squared. What was x times negative 6? Negative 6x. What was 2 times x? And what was 2 times negative 6? Okay, then the two terms in the middle ended up adding up to like terms because they're exactly the same term. They have the same variable. So this would become x squared minus 4x minus 12. Now here's what's happening today. Today you're starting with this, x squared minus 4x minus 12, and you're trying to take me back to what two factors got multiplied to give me that total. So that's called factoring. And factoring is eventually going to lead us to solving equations. These aren't equations yet, but we're eventually going to set them equal to something and use factoring to solve them. Yes, question. Yes, quickly. Okay, so we're going to go backwards. We're going to start with this, and we're going to go backwards to this step. We're going to figure out what two numbers got added up to give me that middle term. And then we're going to take that backwards to this step, and we'll end with two binomial factors that you would multiply together to get that product. And this is a new method I just learned this summer, so I'm excited to try it with you guys. First period seemed to get it, right, Isaiah? I'm sorry, bear power time. Let's start with this one. X squared plus 8x plus 12. First of all, we're going to start off with easy ones. In this problem, all the signs are positives. That makes your life a little bit easier. I think so. Okay, now, the way you start is to think about where we got this number right here. That came from the last two parts of the binomials, got multiplied together to give you a positive 12. So we're going to list all the things that could multiply together to give a positive 12. Starting with the smallest thing you can think of, which is always 1. 1 times 12. Okay, so I'm going to make a little chart over here to the side for all the factors of 12. 1 times 12. What else? 1 times... Okay, so we have 1 times 12. Think of the next number that will go into 12, which is 2. 2 times 6. 3 times 4. Well, 4 times 3 and 3 times 4, same thing. So I think we've pretty much got all the pairs, right? Okay, now, not only did they have to multiply to give 12, they have to add up to the middle term. That's where the middle term comes from, two products getting added together. Which pair of factors here could add up to an 8? This is the winning combo right here. So this gets us to that second step. We're going to rewrite 8x. Instead of as 8x, we're going to write it as 2x plus 6x. Okay, so this trinomial before the middle terms got added up was x squared plus 2x plus 6x plus 12. Okay, so we took it backwards one step so far. Are we okay with that? Now, GCF is important for factoring in this method. You are now going to pair them up, the first two and the last two. And you're just going to look at those two pairs and think of what GCF you could take out of each pair. For x squared plus 2x, what can I take out of these two? An x. So I'm going to factor an x out. If I factor an x out of x squared, what's left? X. If I factor an x out of 2x, okay, so I would be left with x plus 2, right? And if you multiplied this back, you would get x squared plus 2x. Now, the next group, the 6x plus 12, what's the GCF there? So we're going to factor out a positive 6. What's left from this? Just an x. What's left from the 12? Okay, and we're almost done. You should always end up with the same total in these parentheses here. If you don't, then you did something wrong. This should always work out to where once you take out the GCF from your two pairs, you should have the exact same amount in the parentheses. Okay, now, this is where it's a little weird. We haven't done one like this. This is a product, and this is a product. And they both have a common factor. Of what? X plus 2. They have a whole x plus 2 in common. Don't you see there's an x plus 2 times x here? There's an x plus 2 times positive 6 here. We're going to take out the x plus 2. So I'm going to take out the x plus 2 from this group. So if I take this out, what's left? X. And if I take this out, what's left? The plus 6. These are the two factors that would give me this product. And how can I know if I'm right or not? Multiply it back. Your answer should always equal your question. And if you just want to check your work, multiply it back out and make sure you get x squared plus 8x plus 12. X times x, x squared. X times 6, 6x. 2 times x, 2x. And 2 times 6, 12. That would give me x squared plus 8x plus 12. That's absolutely what I started with, so I can give myself a smiley face that I did it right. What do you think of that? No. Let's try another one. I think the more we do, the easier it will become. Okay, let's do another easy one that's a plus plus. How about x squared plus 3x plus 2. This one's really easy. Okay, now, the last number is what you want to look at first, because that's where you got to make your list of possible products to give you a positive 2. 2 is easy. There's only one way to get a product of 2. 1 and 2. Now, your winning pair also have to add up to the middle term. Do these two add up to the middle term? Yes. 2 plus 1 is also going to give you a 3. So we're going to rewrite this. We're going to break apart 3x into a 1x and a 2x. So this becomes x squared plus 1x plus 2x plus 2. Doesn't that still equal x squared plus 3x plus 2? Okay. Now you're going to pair them up. I'm going to pair up the first two. I'm going to pair up the last two. And I'm going to take out the GCF. What's the GCF of x squared and x? And what am I going to be left with? X plus 1. What can I take out of these two? A positive 2. And what am I left with? X plus 1. Do you see how I ended up with the same amount in the parentheses? That should always happen. And if it doesn't happen, you're doing something wrong. Okay, now I'm going to factor out the whole x plus 1 factor. I'm going to take the x plus 1 out of this, and I'm going to take the x plus 1 out of this. And remember, when you take out a GCF, you always write it out to the front, and then you multiply it by what's ever left. What's going to be left out of this group if I take out this whole x plus 1? An x will be left. What's left out of this group if I take out the whole x plus 1? Plus 2 would be left. Okay, and if you multiply this is my winning pair of factors. Please make sure you write your answer like this. Some kids want to do this to me for some reason. We're trying to find the factors that multiplied to give this. There's no symbol in between these. They're getting multiplied, so don't do that. But if I want to know if I'm correct, what do? Check it. Multiply it back and make sure you get what you started with. This would give me x squared plus 2x plus 1x plus 2. And sure enough, 2x plus x is 3x. That's the winner. Let's move on to one that's just a little more complicated, where the signs aren't going to be plus plus for us always. Okay, how about this one? X squared minus x minus 6. Now, when your last term is negative, What does that tell you about your signs? One has to be negative and one has to be positive. That's the only way to multiply two things and get a negative number. So we're trying to get a product of negative 6. Now when your product is a negative 6, you got to think about your different sign combinations. Okay, usually I just write down all my pairs first. What's the first pair I can get a product of 6? 1 and 6. What else? 2 and 3. Anything else? Okay, now I need a pair that can add up to the middle term. What's my middle term? Negative 1. I need something that can add up to a negative 1. Yeah, 2 and 3 could add up to negative 1 if the 2 was positive and the 3 was negative. That gives me a negative 6 when I multiply them, and it gives me a negative 1 when I add them. Are you with me? Okay, so now I can rewrite this as x squared plus 2x minus 3x minus 6. And doesn't that still equal x squared minus x minus 6? Okay, so now I'm going to do my pairing. I'm going to pair up the first two and pair up the last two. What can I take out of the first two? I can take out an x, and what am I left with? 1x plus 2. Now, this is where you got to be real creative here. I need to have an x plus 2 left over from the next pair. What do you think I need to factor out? I need to factor out a negative number. What's the GCF of 3x and 6? 3, but I don't want to just take out a 3. I need to take out a negative 3. So if I divide a negative 3 out of negative 3x, what's left? X. If I divide out a negative 3 from negative 6, what's left? Plus 2. And again, you should always make sure that you have the same amount in your two parentheses. Now I'm going to take out the whole x plus 2 factor. So I'm taking out x plus 2 from this group, and I'm taking out x plus 2 from this group. And I always write my GCF out to the front and multiply by whatever's left over from the groups. So what's left from this group? X. And what's left from this one? Minus 3. There's my winning combo. Let's make sure it works. What's x times x? X squared. X times negative 3. Negative 3x. 2 times x. Positive 2x. And positive 2 times negative 3 is negative 6. And what do those two in the middle add up to? Negative 1. That's got to be the winner. So there's no wondering if you got it right. Check your answer. You ready to try one on your own? Okay, how about this one? X squared plus 4x minus 21. Again, look at your last number. What kind of number is it? It's negative. So what do you know about your two terms that multiply to give it? One has to be positive and one has to be negative. Now, what do they have to add up to in the middle? A positive 4. Okay, so list all the factors you can think of for 21, starting with 1 and 21. It does matter because you got to look at what they're supposed to add up in the middle. Well, the winning combo here is going to be 3 and 7, right? Now they're supposed to add up to a positive 4. So what should your signs be if it's got to add up to a positive 4? Okay, but which one's positive and which one's negative? This is my winning pair right here. How could a 3 and a 7 add up to a positive 4? So which one's negative and which one's positive then? The 3 has to be negative and the 7 has to be positive, because that still multiplies to give negative 21, and that adds up to positive 4. Did y'all find the answer? What'd you get? Alright, I'm not sure if that's right because I didn't finish. Let me check it. X times x is x squared. Then I'd get positive 7x. Then I'd get negative 3x. Then I'd get negative 21. And those two add up to positive. That's right. That's the winner. They add up to positive 4x in the middle. If you didn't finish, look up here. What we would have done is paired these up. GCF here was x, and you're left with x minus 3. I should have an x minus 3 over here as well. So what should I take out in this case? A positive 7. Divide out a positive 7, and sure enough, you're left with x minus 3. Now you're going to factor out that whole x minus 3 factor, and you're left with x plus 7. You could have x plus 7 times x minus 3, absolutely. What you cannot have, this would not be correct. What if you had somehow ended up with x plus 3 times x minus 7? Why would that not work? That would give you a negative 4 in the middle, and we're not supposed to have a negative 4. So that's not correct, but the order of the factors can be switched. You could have the x plus 7 first and the x minus 3 second. That's fine. Okay. How about this one? Let's do one where the last number has a whole bunch of factor possibilities. Okay, x squared minus 7x minus 60. 60's got a whole bunch of possibilities. This is where your divisibility rules will help you. Of course, 1 always goes into any number. 2 will go into a number if it's, what? Even. How can you check to see if you can divide by 3? Add the digits. Okay, it's kind of obvious that 3 will go into 60, but 6 plus 0 is 6. And if the sum of the digits can be divided by 3, then the whole number can be divided by 3, so I definitely can divide by 3. Sometimes you just have to test it. How about 4? 4 does go into 60 as well. What else do you know should go into 60 right away? 5, because it ends in a 0. Also 10, because it ends in a 0. So there's a whole bunch of possibilities for 60. You're looking for the magic pair that adds up to negative 7 in the middle. All right. Good luck. You already found it? Wow. Did y'all figure out what pair it is? What pair is it? 5 and 12. Now, the signs do matter. The 12 has to be negative and the 5 has to be positive. So this would break apart into x plus 5x. X squared plus 5x minus 12x minus 60. Okay, and here's another one where you got to get creative. Depending on how you placed it, I put my 5x first. So I factored an x out of the first pair, and I was left with x plus 5. What should I factor out of my second group then? I need to factor out a negative 12 so that I'm sure that I'm left with x plus 5 again, and I will be. And now I can factor out the x plus 5, and what am I left with? X minus 12. And if I checked that, it would definitely work. I'd get x squared minus 12x plus 5x minus 60, and sure enough, that adds up to negative 7x in the middle. Okay, now this is one we haven't done yet. Look at this situation. X squared minus 11x plus 28. What's different about this? Yeah, the last term's positive, but the middle term is negative. So what does that tell you about your signs, David? You said it? Both of them have to be negative, because isn't a negative times a negative equal to a positive number? So the only way to have a positive number here and a negative number in the middle is that both of your factors have to be negative. You think you can try this one on your own? All right, try it. Yep, I'm giving you guys time to work it out. Are y'all done? Okay, what pair of factors worked? It had to be a minus 4 and a minus 7. So this breaks apart into x squared minus 7x minus 4x plus 28. When I break apart that 11x. Then pair them up. I took an x out of the first two and I was left with x minus 7. What should I take out of the last two? A negative 4. Okay, and you're going to be left with x, and then 28 divided by negative 4 would give me a minus 7. Remember, you want to make it to where you have the same thing left in your parentheses. Then you can take out the whole x minus 7, and you're left with x minus 4. And that's the winning combo. And again, the order can be different. You could have x minus 4 first and x minus 7 second, same thing. All right, do you think you're good with this? Okay, your homework for this section is going to be page 175. Let's do 1 to 31 first column. That's only 11 problems. Page 175, 1 to 31 first column.